All right, welcome everybody. Just like to have a word from our sponsor. This math video is sponsored by Raid Shadow Legends. I have no idea what this guy's name is, but they paid me a lot of money to put this game up. You know, Raid Shadow Legends. You've tried the fun games, now try this one. All right, anyway, so let's get started. We're going to be covering two anchor charts today. And the general theme is trigonometry. Trigonometry being the metry, the measurement of trigons. What are trigons? Trigons are three-sided shapes, also known as triangles. Okay. Now, the first and most important thing in trigonometry is knowing how to talk about which side is which. Now, we've already seen one scheme for labeling the sides of a right triangle, okay? When we were studying the Pythagorean theorem, what was important was the distinction between two things, the hypotenuse and the legs. Okay. Now we're actually not going to be doing the Pythagorean theorem, and so it's going to help us to look at the sides in a different way, from a different perspective. What perspective, you might ask? From the perspective of the angle and not the right angle. So it could be either angle of the triangle. We'll say it's this one. And remember, that symbol is theta, not 0. Okay? And because this is from theta's perspective, I'm just going to draw a little theta up in the corner saying, it's all about me. Okay? Way to make it all about you, theta. Now, what exactly will we be talking about here? Basically, we're going to be labeling sides from the angle's perspective. So imagine you're this little angle over here, right? And you're looking at the different sides, okay? And the first thing you might notice is that there's this big one that's towering over you, casting a shadow. We're going to call that one the hypotenuse, just like we did in the Pythagorean theorem, okay? And then you might look over across the way and notice that, oh, look, there's a side that's opposite me. So we'll call that the opposite side. And now I'm going to try my best to write side. Actually, I'm not going to write sideways. I'm just going to do it like this. Okay. Why torture you guys, right? Making you watch me write sideways. So you've got your hypotenuse that's over your head. Well, not always over you, but like you got the hypotenuse that's the longest side. You got the opposite side, which is across from theta. And then theta's got the side that's closest to it, the shortest side that's closest to it, and that is the adjacent side. Okay, adjacent meaning next to, right? So the adjacent side is next to theta. It's adjacent. Okay, so let's define these sides really quick, just in terms of words, so that we know precisely why they are what they are. So the opposite side, and remember, this is all relative to theta, okay? So if we had been looking at the other angle, the opposite and the adjacent sides would change, okay? But the opposite side from theta is the side not touching theta. Okay. Actually, let's do theta, just to stay consistent, let's do theta in turquoise again. Okay. The adjacent side, the adjacent side and it's adjacent to theta, is the shorter side, or the leg. Which one should I write? I could write either one. Let's say the shorter side. Touching theta. Actually, you know what? Let's do leg. Let's say leg. And you know what? Let's call this one a leg too. Just because they're always going to be legs. The leg touching theta. Okay, if you want to write shorter side and side, that's fine too. It doesn't matter that much. Either way, it's correct. Okay, and finally, the hypotenuse. Now the hypotenuse is the one side that stays the same no matter which angle you're looking at. So whether you're looking at theta or you're looking at the complement of theta over here, hypotenuse is always the side opposite the right angle or the longest side of the triangle. Okay, so just like when we were doing the Pythagorean theorem, anchor chart, the hypotenuse is the longest side of the triangle. Okay, now one thing that students commonly mess up is that they think that because I've drawn the diagram like this must mean that the opposite side is always on the right and the adjacent side is always on the bottom. And no, that's not how this works. And to show you that, let's do another example. Okay, it actually doesn't matter whether the side is on the right or the left or the top or the bottom. Okay, what we care about is what angle we're looking at, because remember, this is all about theta. Okay, this is all about theta. Right? So where is the opposite side? Well, we need to find the leg that's not touching theta. Okay, this is the leg that's not touching theta, so it's the opposite side. Okay. Now take a moment and try to see if you can find the hypotenuse and the adjacent side. Okay, hopefully you've paused the video, you've had some time to think about it. Okay, so over here is the hypotenuse. Okay, and then over here we've got the adjacent side to theta. Okay. If theta had been over here, opposite and adjacent would have switched. Hypotenuse would have been the same. We don't usually treat the right angle as theta, just because it makes things a little weird. Yeah, I think generally when we're talking about sides relative to angles in a right triangle, we're looking at one of the two acute angles. Okay, the non-right angles. Okay. All right. Hopefully this makes sense to you. Let's continue to the second anchor chart.